In this video, we're going to focus on synthetic division. The aims are divide polynomials by synthetic division without remainder, with remainder, and task to check your understanding. At the end of this video, I would like to check your understanding, so I prepared a task for you. Comment below your answers or questions about dividing the polynomials using synthetic division. You will see this task again at the end of this video. Here, to divide synthetically, number 1, the divisor must be a binomial that can be written x minus c, and only c is used from the divisor. So for example, here we have x cubed plus 2x minus 3 divided by x minus 3, wherein our divisor is x minus 3. Since we're going to use only the value of c, we can equate x minus 3 into 0 and solve for x. So plus 3 for both sides. So x is equal to 3. So our divisor will be number 3, or positive 3. Same way if we have x plus 2. In shortcut, you can just get the inverse of plus 2, and that is minus 2. So that's how we get the divisor in dividing synthetically. Number 2, the dividend must be written with powers of the variable in descending order. Only coefficients of the dividend are used, and 0 is used as a placeholder for any missing variable term or constant. So for example, here we have x cubed plus 2x squared plus 4x minus 3 divided by x minus 3. So the coefficient of the dividend that's gonna be used, and we need to arrange the powers in descending order. Right here, powers is already in descending order, and the coefficients are 1, 2, 4, and negative 3. If we want to find also the divisor, so we just have to find the inverse of minus 3, and that is positive 3. On the other hand, we have here x cubed plus 2x minus 3. So the value of x squared is missing, so we're going to replace it by 0. That would turn into 1 for the x cubed. Now we don't have the x squared, so we're going to use 0, then followed by 2 minus 3, and our divisor will be the inverse of minus 3, which is positive 3. Now let's apply that. Here, divide the polynomials by synthetic division, and this example is without remainder. The given is x squared plus 5x plus 6 divided by x plus 2. For our divisor, the c here is plus 2 or positive 2, and inverse of that is negative 2. Then we're going to draw the line for the synthetic division. Then check if the powers is in descending order and if it is complete. Here we have 2, 1, then constant. So it's in descending order and it's also complete. Now let's write the coefficient of each term. So for x squared, that is 1, x is 5, and the constant, which is 6. Then let's solve. Bring down the first number, that is 1. Then we're going to multiply negative 2 times 1, which is negative 2, and we're going to write it over here. Then we add 5 plus negative 2 is positive 3. Then multiply negative 2 times 3 is negative 6. I'm going to write over here. Then add 6 plus negative 6 is 0. So we're going to multiply, add, until we get to the last number. Now we're going to rewrite our answer 1, 3, and 0. Since the highest power here is x squared and our divisor is x, So we're going to divide x squared divided by x, and that is x. So the first number here will be x. Okay, then the 3 will be our constant. Just simply like multiply the first number by the x, which is x times 1, and that is x. And then the power should be descending as well. So from x to the power of 1, then x is the constant. So our answer is x plus 3. Another information is that since our answer here is 0 to the last, which means that this x plus 2 is a factor of x squared plus 5x plus 6. Another example, we have 3x cubed minus 7x squared minus 11x plus 15 divided by x minus 3. Let's get the inverse of the value of c. From negative 3 become now positive 3. Then let's draw the line. Then check again if the powers of your variable is in descending order. So from 3, 2, 1, then constant. So it's already arranged. Now let's write the coefficient of the variables. So from x cubed it is 3. Then for the x squared it is minus 7 or negative 7. Then for x it's negative 11 and the constant 15. Let's start. Bring down the first number. That will be 3. And then we are going to multiply 3 times 3, that is 9, and we're going to write the answer right here. And then we're going to add negative 7 plus 9 is positive 2. Then we multiply again 3 times 2, that is 6. And then we add negative 11 plus 6 is negative 5. Then 3 times negative 5 is negative 15. So 15 minus 15 is 0, or 15 plus negative 15 is 0. Now to rewrite this, so if we're going to divide x cubed divided by x, that is x squared. So our 3 here will become 3x squared. Then the 2 will become plus 2x. The constant will be minus 5. So here's our answer, 3x squared plus 2x minus 5. Here we have x cubed minus 1 divided by x minus 1. Starting with our divisor, the value of c is negative 1. Inverse of that is positive 1. And then let's draw the line for the synthetic division. For our dividend, x cubed minus 1. We don't have x squared and x, so we're going to replace them as 0. Now let's write the coefficient of the x cubed, which is 1. For x squared, we don't have it, so we're going to replace that for 0. For x will be 0 as well. And then the constant, negative 1. Then let's solve. Bringing down the first number, that is 1. Then we multiply 1 times 1 is 1. Then add 0 plus 1 is 1. Multiply 1 times 1, that is 1. Then add 0 plus 1 is 1. Multiply 1 times 1 is 1. Then add negative 1 plus 1 is 0. Now we're going to rewrite our answer here. So divide x cubed by x. X cubed divided by x is x squared. Or just simply subtract 1 to the highest power of your dividend. So from 1 it will turn into x squared. Then this will turn into plus x. And here will be the constant will be plus 1. Remember, our answer should be in descending order. So from x squared, x, then constant. So this is our answer. X squared plus x plus 1. Here, divide the polynomials by synthetic division with remainder. So if our answer is with remainder, our answer should be in the form of quotient plus remainder over divisor. Let's try this. M squared minus 7m minus 11 divided by m minus 8. For our divisor, the value of c is negative 8. Inverse of that is positive 8. Then let's draw the synthetic division line. Afterwards, look at your powers. It should be in descending order for your dividend. We have here 2, 1, then constant. So it's in order and there's no missing term. Now let's write the coefficient of m squared, that is 1. M will be negative 7. Then the constant negative 11. So let's bring down the first number, that is 1. Then multiply 8 times 1. We're going to write it over here, which is equal to 8. Then add negative 7 plus 8 is 1. Then multiply 8 times 1 is 8. Add negative 11 plus 8 is negative 3. Now we're going to rewrite our answer. So from m squared, it will become m. So bring down 1, that will turn into m, followed by the constant plus 1. Then the remainder will be minus 3 over the divisor is m minus 8. M minus 8. So this is our answer. M plus 1 minus 3 over m minus 8. Next example, we have 2x cubed plus 3x squared minus 4x plus 8 divided by x plus 3. So the value of c is positive 3. Inverse of that is negative 3. Then let's draw the line of synthetic division. Then check if the powers is in descending order. 3, 2, 1, then constant. And it's also complete. Now let's write the coefficient. Starting with 2, 3, negative 4, and 8. Now let's solve. Bring down the first number, 2. Then multiply. Negative 3 times 2 is negative 6. Then add 3 plus negative 6 is negative 3. Multiply negative 3 times negative 3 is positive 9. Then add negative 4 plus 9 is positive 5. Multiply negative 3 and 5, that is negative 15. Then add 8 plus negative 15 is negative 7. Now we're going to rewrite our answer. So from x cubed minus 1 to the power, it will be x squared. The 2 here will turn into 2x squared. The negative 3 will turn into minus 3x. The 5 will turn into our constant term. Then our remainder will be minus 7 over our divisor, x plus 3. So here's our answer. It's now time to check your understanding. Pause the video and comment below your answers or questions about dividing the polynomials using synthetic division. And remember, math is more than a procedure. It's a powerful habit of thinking.